guys, welcome back to another discrete math tutorial. In this tutorial I thought we'd go ahead and continue on with logical equivalency examples. And basically in this problem what we want to do is show that the following compound propositions are logically equivalent. In this case, P if and only if Q is stating that it's logically equivalent to P and Q or not P and not Q. Well, because this segment is already nice and cleaned up from these hideous if and only if statements and there's no implications and everything like that, I'm going to go ahead and start off with this side and try to work my way into this side. We may come to a point where we need to get this side worked as well to try to get to a point where these two are identical on both sides. So let's go ahead and start. Well, what is P if and only if Q? Well, that states that P implies Q and Q implies P. The following step, like I said, we want to get rid of these nasty implication symbols. So let's go ahead and do not P or Q and not Q or P. The following step, we want to go ahead and distribute this entire section over to this. I mean, that's the only logical thing that I can see since I can't really do anything, and this portion really doesn't match this portion. So I can see that the negation symbols are on one side and the one with the non-negation symbols are on the other side. Here we have a negation symbol on one side and the other side. So let's go ahead and distribute this entire section over. So what does that come out to? Well, we're going to distribute the not P or Q and not Q. Then we have our or symbol right here. So again, we'll distribute not P or Q or P. Oh, I'm sorry, and P. Almost tricked me there. As you can see, we distribute this portion right here to first to here and then to here. The or is basically the connective that goes inside here. So now that we're at this portion, at this step, let's go ahead and rearrange this a little bit because we'll be continuing our distribution, and it just makes it easier from left to right versus trying to figure out exactly from right to left how to distribute this. So not Q and not P or Q, or, and then we have in here P and not P or Q. Alright, now that we got this step, we'll go ahead and distribute this not Q and to the inner portion of the parentheses right there. So that comes out to not Q and not P, or not Q and Q. Got one side done. Let's go ahead and do the other side. Comes out to P and not P, or next step P and Q. Alright, so P and Q. Now that we're here, let's go ahead and finish this segment off. Well, there's nothing really we can do with not Q and not P, so we just rewrite it. Or, well, there we go. Not Q and Q. What does that come out to? That comes out to false. Continue on by or. Same thing here. P and not P is false. False or P and Q. Now that we have this, well, remember we can get rid of our false by just replacing it with whatever's over here. If you guys remember, this side will dictate the truth value. So if this was true, true or false is true. This segment was false, false or false is false. So that's why we can just go ahead and get rid of this false symbol. So that comes out to not Q and not P, or P and Q. Alright, as you can see, we got our negation symbols on one side and our non-negation symbols on the other side. So let's go ahead and rearrange this a little bit. See if we can get it to match this side. So this or symbol right here, the disjunction symbol, we can go ahead and swap these around. That comes out to P and Q, or not Q and not P. Alright, well, in here we have not P and not Q. Well, that's easily swappable as well. That comes out to P and Q, or not P and not Q. And guess what? This statement right here does in fact match this statement. So that states that P if and only if Q is, as a matter of fact, logically equivalent to P and Q, or not P and not Q. Let's try one more example. This time we'll assert that the negation of P if and only if Q is logically equivalent to P if and only if not Q. Alright, in this segment, I'm pretty sure we're gonna have to work out both. Actually, I'm confident, because like I said, I don't like these if and only if symbols, and I don't want to go backwards. So let's go ahead and work out both sides. I'll start off with the left side. What is P if and only if Q? Well, we just went over that. P implies Q, and Q implies P. So now let's get rid of the implication symbols, and that comes out to not P or Q, and not Q or P. Alright, moving on, let's go ahead and distribute the negation to inside here. Well, that comes out to not P or Q. We gotta swap our symbol here to an or, and then we distribute the negation to this statement right here, and that comes with not Q or P. Let's work a little bit further and distribute the negation inside as well. So that comes out to P and not Q, or Q and not P. Alright, does this statement first of all match this one? Well, let's see what we can do with this one. So that comes out to P implies not Q, and not Q implies P. At this stage, we want to get rid of the implication symbol, so we get to not P or not Q, and Q or P. So the reason why it's Q and not Q is because the negation of a negation is just the opposite of the negation. So Q or P. Well, do these two match? No, they don't. So what are we gonna do right now? All right, I'm just gonna go ahead and continue working on this one and distribute this segment inside here and see if we can break apart these negation symbols, because I notice that there's a negation symbol here and a negation symbol there. Not P or not Q and Q, or not P or not Q and P. Alright, let's go ahead and distribute the Q and not P, or Q and not Q, followed by the distribution of this P and inside here. So that'll be P and not P, or P and not Q. Let's see what we can do with this. Q and not P, or false, or P and not P. Well, that's just false. False, or P and Q, or not Q. Now at this segment, remember, we can get rid of our false truth values, and let's go ahead and what is left over? Q and not P, or P and not Q. Let's see if this matches anything. There's our P and not Q, and there's our Q and not P. So with this disjunction, we can just flop these around. So P and not Q, or Q and not P, which, as a matter of fact, is equivalent to this statement right here. So these two sides are logically equivalent. As you can see, sometimes it's not as easy as just working out one side and trying to get to the other side. Sometimes you actually have to do both sides in order to go ahead and verify that the two statements are, as a matter of fact, logically equivalent. We could continue on and get back to these stages, but for right now, we're just going to go ahead and leave it off right here, since this satisfies the definition of logical equivalence. Well, I hope you guys learned something new today. As always, make sure to subscribe to my YouTube channel for more discrete math tutorials.